First method we discussed negative remainder concept. Negative remainder concept. We discussed what is a negative remainder concept. Then we understood the drawback. Then we discussed Euler theorem concept. Euler theorem concept. In this Euler theorem concept, we have discussed what is a totient function. What is a totient function? Euler's theorem is used when the denominator is a composite number. When the denominator is a composite number. Then we thought, what if the denominator is a prime number? If the denominator is a prime number, if the denominator is a prime number, if the denominator is a prime number, then we discussed another theorem, Fermat's theorem. Fermat's theorem. These are the three concepts which we discussed. In negative remainder, we discussed using models, model 1, 2, 3, till 6 models which we have discussed. And the seventh one is power to the power. 7 models we have discussed in negative remainder concept. Euler's theorem. In Euler's theorem, we also discussed how to find the digital sum. How to find the digital sum of a number. It is nothing but the remainder when you divide a number by 9. That also we used it. Then we discussed denominator prime number. Students who missed out the session 1 and session 2, you can go back to our YouTube channel and the videos are made public. You can watch session 1 and session 2 to get all your doubts clarified. If you are listening to session 3 for the first time, if you are listening to session 3 for the first time, if you are listening to the class for the first time, now see here, right? So in Euler's theorem, we also discussed backtracking method, how backtracking helps us. Today, by today evening, reminder, most of the problems you can solve it. This we solved, this we solved. Let me do question solved, question solved. Question solved, question solved. 5 over 6, 7, 8, 9, 10, 11, 12, 13, 14. Practice problems which we solved. Write all these. Euler's theorem. Euler's theorem. Euler's theorem application. Fermat's theorem. Now we are at. Please write down an important key point. Then we will solve the problems. Please write down. Fermat's theorem, one important conclusion. Fermat's theorem. Let me first discuss what is Fermat's theorem. Fermat's theorem is remainder when a power p minus 1, when divided by p, it is 1. When a and p are co-prime numbers. When a and p are co-prime numbers, p is a prime number. P is a prime number. Remainder when a power p minus 1 when divided by p, remainder is 1. Remainder when a power p minus 1 when divided by p is 1. A and p are co-prime. For me, this is not important. The conclusion of this, I will discuss the proof. Any single digit, any single non-zero digit, any single non-zero digit written p minus 1 times, any single non-zero digit written p minus 1 times, p is not equivalent to 235 is always divisible by, is always divisible by p if p is prime. First write this point, then I will discuss the proof behind this point. It's an extreme important concept. You take any single non-zero digit. You take any single non-zero digit. If a single non-zero digit is written p minus 1 times, p is not equivalent to 2, 3 and 5. P is not equivalent to 2, 3 and 5. It is always divisible by p if p is a prime number. If p is a prime number. Any single non-zero digit. written p minus 1 times is always divisible by p if p is a prime number. For me, important key point is p is not equivalent to 235 and a single non-zero digit is written p minus 1 times. Why it is happening? Proof. For everything whatever I discuss, I will give you the proof. Please write down. Can I say that 10 power p minus 1 divided by p, it is 1 if p is not equivalent to 2 comma 5? Because Fermat's theorem is valid when the numerator base and the denominator are co-prime to each other. If I take 2, 10 and 2 factor common is 2. 10 and 2 are not co-prime to each other. 10 and 5 are not co-prime to each other. So 10 power p minus 1 divided by p is 1. Suppose example 10 square divided by 3, 100 divided by 3, 333s are 99, remainder 1. Can I write like this? 10 square minus 1 divided by 3, remainder will be 0. Can I write like this? 10 square is 100, 100 minus 1 is 99, 99 when divided by 3, remainder will be 0. Am I right? Now please write down these example. Then in the next slide I will give you a proof. 10 power p minus 1 when divided by p, it will be 1 when p is not equivalent to 2 comma 5. Why p cannot be equivalent to 2 comma 5? Because a and p should be co-prime to each other. Because a and p are co-prime to each other, so 10 and 2 are not co-prime to each other, 10 and 5 are not co-prime to each other. Now see here, proof. Reminder 1, 10 power p minus 1 divided by p, it is 1. P is not equivalent to 2 comma 5. So if I keep 1 on the left hand side, this will become 10 power p minus 1 minus 1 divided by p, it is 0. If I take p value 3, this is nothing but remainder of 10 square minus 1 divided by 3. This is nothing but 10 square minus 1 is 9 into 1 divided by 3, which is 0. Am I right? 9 is divisible by 3. 9 is divisible by 3. If I take p value 7, 7 minus 1 is 6. 10 power 6 minus 1 divided by 7. 10 power 6 minus 1 is 9 written 6 times. 1, 2, 3, 4, 5, 6 divided by 7 and it is 0. 9 is not divisible by 7. 9 is not divisible by 7. Only in this case 9 will be divisible by 7. 9 is not divisible by 7, but these 6 once is divisible by 7. 9 is not divisible by 7. 6 once is divisible by 7. Now what is the point I said? Any single non-zero digit written p minus 1 times is always divided by p. Why p is not equivalent to 2 comma 5? Because p and 10 are co-prime. Why p cannot be equivalent to 3? Why? Because 9 is divisible by 3. Any single non-zero digit, extremely important point, sir. Any single non-zero digit written p minus 1 times, is always divisible by p. If p not equivalent to 2, 3 and 5. Please write down. Any single non-zero digit written p minus 1 times is always divisible by p. P is 2, 3, 5. 9 is not divisible by 7. 6 once is divisible by 7. I hope the proof is clear. Unless you understand the why behind the question, which method to use when, you will not have a clarity. At the end of session number 3, I will give a table when to use which concept, so that complete reminders will be clear. So any single non-zero digit written p minus 1 times is always divisible by p if p is not equivalent to 2, 3 and 5. If p is not equivalent to 2, 3 and 5.